Now, whatever you guys have seen is just a reflection of light, correct? So if it's on a plane mirror or a plane surface, or it's a spherical surface or some irregular surface, whatever it is, it's all reflection. Now you guys will talk about refraction. Okay, now you guys already know what is refraction, right? So when a ray of light which travels from one homogeneous medium to another homogeneous medium, the direction of the light will change. So this phenomenon is refraction, right? Now there are certain laws of refraction which you guys have to know. In that, the first one is the incident ray, the normal and the refracted ray all lie in the same plane. This is first one. The second law, so this law is important. This is what we call as Snell's law. Okay. Now what Snell's law tells is the sine of the angle of incidence to the sine of the angle of refraction. The ratio of these two is always constant for a given two media. Meaning, so suppose let's say you have medium A and medium B, and this is how the light is moving. Okay. Now what we have is A mu B is equal to sin I by sin R. Now this A mu B is what we call as refractive index of the material. Alright. So here the light ray is moving from medium A to medium B. That's the reason we write it as A mu B. So A mu B is equal to sin I by sin R. So sometimes you also represent it as A and B. Okay, N is also refractive index or mu is also refractive index. Anything. Alright. So this is Snell's law. Fine. Then the third, you can say law. Now the same refractive index can also be represented in terms of the velocity of light. Okay. Now here the velocity of light, let's say in medium A is V1 and the velocity of the same light in medium 2 is V2. Alright. So we have A mu B is equal to V1 by V2. Okay. The ratio of the velocities will also give you the refractive index of the material. Okay. Now there are certain special cases. See, if the light ray is traveling from vacuum or air to any other medium, let's say water or glass or whatever it is. So here what we say is the absolute refractive index, because the speed of light in air or vacuum is 3 into 10 to the power of 8, correct? That's the value of C. But once it enters the medium, the velocity will change. So we have mu is equal to C divided by V. Okay, so this is the absolute refractive index. Fine. So these are the same refractive index itself, but in a different ways of representing it. So here a very important note: whenever the light travels from one medium to another medium, the speed will change and the wavelength will change, whereas the frequency will remain the same. Like suppose let's say you're sending red light from water to, let's say, glass. Here the speed will change, the speed will technically it will decrease, and even the wavelength will also change, but the frequency will remain the same. So if you send a red light through glass, you don't expect an orange light or yellow light coming out of it. Okay, so you do not do that. So remember this point very well. Speed will change and the wavelength will change, whereas the frequency will remain the same. Okay, so in the next video you will see the same thing but different laws and experiments on refraction.